The states of matter are gas, liquid, and solid. Gases assume the shape and volume of their container. Particles of a gas are separated from each other, move in straight lines, and in a completely random manner. They change direction only when they collide with each other or the container. Liquids have a definite volume and assume the shape of their containers. The particles of a liquid are closely spaced, and so their motion is still random but much more limited. The particles slip past and collide with near neighbors. Solids have a definite shape and volume. Particles of solids are in fixed positions and collide only with near neighbors.
Okay, we've got Mentos, we've got Diet Coke.
Guess I was right.
Did they all go in?
Yeah, that was cool.
Water is surprising stuff. The most common of compounds, water can be found in nature as a solid, a liquid, or a gas. Sometimes all three states exist at the same time. One of the surprises of water is that it expands when it freezes, making it less dense than liquid water. Consequently, glass containers of freezing water will burst, and ice will float rather than sink. Although water has an unusually high boiling point for such a light molecule, 100 degrees Celsius, water can be seen boiling up to the surface in some hot spots on Earth. The fact that water remains in the liquid state between 0 and 100 degrees Celsius makes life possible in a wide range of environments. Water is probably best known for its dissolving properties. The attraction of water molecules for itself and other molecules makes water very efficient at dissolving many ionic and covalent substances.
Hi, my name is Michael Sweat. I'm a junior at the University of Maryland, College Park. This is Bobby Bruce. He's a grad student here as well. And we're here to tell you about plasma, the fourth state of matter. And we're here researching plasma to find out how plasma can be made to create some pretty amazing phenomena. So I hope you enjoy this video. Thank you. Plasma. It is the basis of some of the most spectacular phenomena in nature. The violent spark of lightning, the luminescent northern lights, Even the burning brightness in the core of every star in the universe all have their origin in plasma. Man-made plasmas include fluorescent light bulbs, neon signs, and plasma televisions. When we think of plasma, we often think of its intense otherworldly glow, which almost seems supernatural. However, plasmas contain underlying physical concepts. So what is a plasma? Let's first look at a gas. A gas has a positive core with the negative electrons orbiting around the core. A plasma is a gas that is heated to the point that the individual gas atoms break apart into a collection of positively and negatively charged particles. The distinct glow of a plasma is created by the occasional recombination of negative and positive charges. This recombination produces an emission of light with a color determined purely by the gas chemistry. In a laboratory environment, plasmas can be reproduced by flowing a gas into a vacuum chamber and igniting this gas with electric power. Depending on the type of gas flowing through the chamber, plasma can take on many rich colors. In the vacuum chamber, you can see argon gas emitting purple light. Nitrogen emits a reddish-orange light, and fluorocarbon emits blue. All of these different colors are specific to the gas chemistries. Plasmas can be used as a controllable, reactive gas. So for example, if we put an object at the edge of a plasma, the charged particles will bombard the object, etching away at the surface. The electronics industry has used this concept to make smaller and smaller patterns into silicon, which is used in laptop computers, cell phones, and a whole wide variety of other applications. Plasma processing proved essential to the rapid miniaturization and increased performance of computers. These plasma processes are integral to the information revolution that is occurring today. Here at the University of Maryland, scientific research will continue to advance our understanding of plasma and its applications to make a better future.